Wait, so it was recording the whole time? Or no?
Yeah, and then I stopped it when I came back in, and now I restarted. So.
Oh, okay.
Yeah, we're having some fun today.
No, we just talked about this stupid.
Yeah, to the radio
Now,
stuff.
here's what gets to be kind of cool. We are starting a new unit. It's like the first day of the lesson, getting going right out of the beginning. And this is my first time teaching physical science. And I look at this next section here, I'm excited to start with it because we're not dealing with a periodic table and letters and numbers and things that honestly you need to have a model to understand what they look at. What we're going to be talking about today and over the next probably 2 weeks here is the physical science side of things that you can actually see and measure right in front of your nose. Okay? The topic that we're going to be looking into is motion. Okay? So my bell ringer right out of the gate is when describing something that is in motion, what are a few things that you might observe while that's happening? How would you know that something's in motion?
Shadow? By how fast it's moving?
Okay, so the speed at which it's moving. Good.
Like maybe by a shadow?
Oh, how would a shadow help?
Like you could like, well,
If it's not always in a
Yeah.
singular spot, you can tell where it's at.
Okay, so it's moved from one place to another? Like that. Does a shadow move?
well, it
Depending
follows,
on-
it follows a
the
person.
object.
Depending on how the object is moving. Yeah, like say the object moves, then the shadow will move sometimes. It would mirror it, but on a surface.
Here's one, just to get you to think a little bit. I'm going to do my best thinker pose like I did 4th hour.
King crosses.
I'm old and smart. Other than me breathing and my heart beating, I'm moving.
Isn't he like Tom
Yes,
like
or
always
just
moving?
barely moving.
Your body's always moving.
Yeah.
What do you mean?
Well,
You've never,
Because
Oh,
you're
my
moving
heart?
up, but
Oh,
this
no,
is
I'm not talking about my heart, but like right now, as I sit here, am I moving?
yes,
Yeah,
It's
your
moving.
chest.
I
I.
mean.
Your
are-
wrinkles are
What?
moving. Your wrinkles are moving.
What if I my wrinkles?
That's crazy.
Oh.
Like
You can't do it.
Oh, and everything.
What if
You can't
I were
say
to
so.
tell you I'm moving at about 900 miles an hour right now?
You're gaslighting us.
Blood flow.
You're gaslighting us.
Your mind.
How am I moving at 900 miles an hour?
Your brain is thinking I'm 900 miles per hour because we stress you.
Your
Your
mind.
heart. Your heart is your
No, you said not the heart.
Your earth moves.
What if I were to tell you right now you're moving about 900 miles an hour?
Not.
Oh,
Oh,
there, that's something. Okay, let's think about this a little bit. Now,
I thought it was just thoughts.
Is that even not good?
the best I can think about. We are spinning
It's just for show.
on our axis, right?
Yeah.
As the Earth. Okay. Does anybody know the circumference of the Earth off the top of their head?
7,000 miles.
3.145.
7,000.
Well, that's the diameter, not the circumference. But if we were to figure out the circumference, you're actually pretty darn close because it's about 25,000 kilometers. And if you take 3.14 times the 7,000, you said you're actually not that far
I
off.
literally said 3.14.
Okay, now, about 25,000 kilometers, okay? Now, a kilometer is a little bit shorter than a mile. And if we are spinning, how long does it take to go from 1:30 in the afternoon to 1:30 in the afternoon again?
24 hours.
24 hours. So that means in 24 hours, we're going about 2,500 kilometers, 25,000 kilometers in that time, which is right around 900 miles per hour. Now, from a relative standpoint, if you think about where we are at on the spinning axis of the Earth, if we were at the equator, would we be spinning faster than if we were we're standing at
No,
a pole?
no.
Wait, say that question one more time? Say
Yes.
that question one more time.
You're
I have
furthest
a-
away.
Repeat your
Yeah, can you
question.
say that one more time?
Repeat your question.
Let me grab a pin for you
A
to
pin.
show this. 2 pins would actually be really nice.
Oh, this is your quick demo?
Well, one of them.
So there's multiple demos. No nuts.
Like I said, this is gonna be the part of science that I'm hopefully gonna be able to show more than sit and think about in terms of like,
You messed up the earth.
I don't know how I'm
What the heck? Sugar?
which pin is moving faster?
The outside one?
Why do you think it's moving faster?
It has like less space to go.
So if it's
It's a smaller
going
section.
less distance
Does that
over the same amount of time, it's actually going
that slower?
slower. Do you think you'd be able to notice if you're moving slower at the pole compared to the equator?
No.
Yeah. Yeah, the
Oh,
daylights
yeah.
and like all that stuff because in Alaska.
That's a little different,
It
you're right.
has
And then we also sit at this like
Alaska.
20 whatever degree angle, that gets to be a
I
little
think it's
close too.
27, isn't it?
3.5. But when we look at things in motion, you guys are exactly right when you talked about we could use a shadow. We could reference it to something else that's not moving, right? Yeah.
So say like, say you're walking at 5 miles an hour and the earth is spinning. Does that mean that you are going 905
We're
miles
doing
an
too
hour?
much.
Which direction are you moving?
Well, does that matter?
Oh,
If you're moving
Yes,
the
it
opposite.
does, actually.
Because you're going from
Now,
outside.
here's the thing, you're asking a very, very, very complex
Yeah.
physics
You
problem.
gotta think less.
Because you're thinking about, as
Try to
this
say
spins
you're
this
doing
way, and I move this way,
You're
how far am I
actually-
really moving?
You're not.
Think about it this way, let's say you're on a
I
train,
would,
right? And if
yeah, so-
me and Tayden are sitting next to each other on the train and it takes off and goes 30 miles an hour, we're both moving 30 miles an hour together. If I look at Tayden, does it look like he's even moving?
No.
But if I look out the window at Courtney as we're moving 30 miles an hour this way, obviously you can tell that we're moving. Now, this is really weird. I think about this as I've looked out the window ever since I was a little kid in the car. You ever look down the rows of cornfields
Yeah.
as you go?
But
They
then
just kind of
like your
bend
eye
behind you.
catches
And
something
it's,
like,
what that is that reference point that you're talking about and how you compare it. Okay? So we're gonna keep things really, really simple first. We're gonna try to set things in a given spot and then measure it from there and then kind of work our way up to some of that angular momentum as things spin. Yeah.
okay, if you're like on a rocket ship and you're like not,
Oh my God.
and you're outside
Whoa.
of Earth, can you see it spinning?
No.
Kind
Kind of.
yes and sort of no. I've watched a, probably could find it
Well,
here
if
in
you
like
see it
30
time-lapse.
seconds, but
You know what I mean?
watch the movie The Martian when they talked about how they needed to intercept things as they move through space and use the gravity of other things to pull it and move it around there. These are the type of high-end complex math questions that I was telling D-Dog about there. So it's exactly right. You have to take all that into account if you want to be able to measure and do those things. So, well, this was like a month ago. Did you guys hear about it when we blasted that meteor out of the middle of outer space?
Yeah.
The bomb?
I mean, they just shot down a China balloon.
Well, that wasn't as hard
China
because that
balloon.
was only like 60,000 feet in the air. This was like
China and Chinese are the same
millions of
thing.
miles away. So that was their big difference there in terms of aiming points and everything else. But let me show you one other, this is my quick demo that I wanted to show. Okay?
And, like,
So I started making a, you're gonna be my baseball catcher here. What we're gonna do, one of the labs that we're gonna do when we look at how we compare things to how they're moving over time is we're gonna start with a start point, which I've got these about as close as I can get together here at 1. And we're gonna videotape as the ball moves its way down, when does it cross 10, 20, 30, 40, 50, so on and so forth, centimeters along the way. What do you expect to happen to the speed of the ball as I let it go down the hill?
It's gonna get faster.
It should pick up speed.
It shall increase.
So,
Well, that is
this is my first time trying this, I told you that, right?
Well, it increased, didn't it?
There we go.
It-
So,
Velocity.
what we will do, now you're getting into a new word that we're gonna talk about, velocity, okay?
Remember when we made
Now, it's funny, I hear exit velo, like you're watching MLB Network and you actually know something about it, but what happens to exit velo as it gets further and further away?
So,
It actually slows down because of the force that it takes to put on it, but as
how the ball spins.
I keep this here
Velocity.
as a constant,
Rate
and
of-
let's say I change my angle, right, it's gonna pick up even more speed yet as we go down there. Now, I told Fourth Hour about a story when I was out in Rapid City, South Dakota, out in the Black Hills for a vacation out there, and we went to this kind of backwoods water park. Now, the reason I say I know it's backwoods is because they had those speed slides, have you ever seen those? Where you kinda go boom, boom, down the hill really, really
And
fast.
then you go boom like that.
All I know is it was like nice and safe and easy down the first little drop. The second drop, there wasn't a single part of my body that touched the slide until I hit the bottom of the slide about 70 feet later.
Ow.
It hurts.
Instant wedgie, ow, was right, yeah. Whoosh, now I'm wondering who designed the physics of that slide, because they just built it on a hillside, okay? A ding dong, yeah, because that, I don't know if that was real safe, and I had to sign like this piece of paper that says if I go down this slide and I get hurt, it's not their responsibility for me getting hurt. That's probably because there wasn't a whole lot of math done to make sure that that slide was safe. And as my grandpa says, they don't make slides in parks like they used to, because these are nice and easy going.
Is it like when kids make slides themselves in this winter, like with the hills and stuff, and then they go way too fast, and then next thing you know, they got two front teeth.
Those were fun though.
They were
The ice
fun.
slides.
Ricky Bobby always wanted to go fast though, so I mean, you gotta go have that fun. It's like
And
the
then
state
and
park
then it
hill.
gets icy, and then next thing you know, everyone's just flying.
Yep, exactly.
And then we can't do it no more.
Designing these things is important. Now, I've got about
Someone gets
3 slides worth of notes. That's it, okay? And then I got a vocabulary worksheet packet for you that's just practice.
Now they play something called Gaga Ball.
I don't know how safe that thing is either. Okay?
Gaga Ball just seems. My brother's gotten hurt so many times in it and has ripped so many pairs of pants. My mom has gone crazy.
Yeah, that thing is not safe.
Yeah, I screwed my necklace on the
So, first slide says, I can explain why all motion is relative. Now, when I use the word relative, there was another fancy scientist that used the word relative to describe how things move in space and time.
Neil
What was his
Armstrong.
name?
Neil Armstrong.
Newton was the start of it.
Wait, so then you-
Einstein.
Theory of relativity
Courtney
was
Peterson.
Einstein, yeah. And they all kind of worked together and built off of what they knew before. Because some of the first people with Newton being almost the first, he came up with some of these first laws that stated that an object that is not moving will stay not moving, and an object that goes in motion will need some sort of force to act upon it to get moving.
These are our notes we're writing,
Okay.
right?
Yep, we want the slides up here. Yep. So when we use the word relative, we're talking exactly what Owen was talking about.
Velocity.
We have to be able to look at how things move in terms of relativity to the other things around it. And when we say that the relative things that are around it, if you can find something that's not moving next to something that's moving, we'll be able to tell the difference in how fast it's changing over time. And that really is what motion is all about, is understanding how things change over time. Now when I teach biology, it's a whole different way of measuring change over time. Whereas if you're doing physics or engineering of things like this, it's all about things that move. How fast do they move? How efficiently do they move? And that fun stuff. So the book we'll describe this as what we call a frame of reference. A frame of reference is the background that we can use to compare an object to. Kind of talked about that. It's like if you're in a train and you're moving, the people standing on the platform will see how much you've moved compared to them. But if I'm sitting next to Tayden, we're going to look like we're moving not at all, because we're sitting next to each other as we move. Okay? Or if you look out and you see a tree that's not moving, or a shadow, like you guys were saying, you can tell how fast you're moving compared to that. So when we describe something that's moving, you have to compare it to something that's stationary.
Maybe because all I can smell is tomato soup.
Eat the soup off your sleeve.
No, you gotta suck it up.
Alright, did you see what happened?
It's all Courtney's fault.
It is all my fault.
Sweatshirt is ruined.
It's not really needs to
Just
wash
tomato
it.
soup.
It doesn't make tomato soup like stain really, really bad.
Yeah.
Oh my god, I had pants that Kaden spilled marinara sauce and I still have yet to get it out of it.
And it's like a light color.
Like you can't afford another one.
Exactly, no, don't even.
Yolanda.
But that was the shit.
Drew, I'm not gonna.
Oh my god.
Oh my goodness.
Oh my goodness.
Almost like you forgot the videotape was running.